Okay. Um, I think we'll start to not to waste your time. So good night or good morning or good afternoon to wherever you are. To everyone, thank you very much for joining us on this webinar. This is actually our first webinar that we're hosting dedicated on AOSP build times, and we'll dive into that in 1 second. I'll introduce myself. My name is Peleg. I'm a PM here at Incredibuild. Here with me is also Dory.
Hi guys, nice to see you all. My name is Dory. I'm a chief evangelist at Incredibuild, been a CTO here for a decade, and highly familiar with all slow build times in the world, large organizations. So I'm here to speak with you on that.
Great. Um, so we'll start with a general introduction to Incredibuild for those of you who are not familiar. Um, Dory, can you press?
Yeah.
So Incredible's been around for a while, over 20 years, close to 25 years, working in the build acceleration space. Started with C++, and over the years, accounting more and more areas of acceleration. Today, we're talking in the company about a universal approach, universal acceleration platform for local or builds or cloud builds or CI/CD pipelines in general, where the main thesis is zero changes to tools and build scripts. Very, very easy to use. Today's webinar will be focused, as we said, on AOSP and its very close brothers in the Linux kernel space, QNX, Yocto, and so on. But the main focus will be AOSP, and I think soon we'll soon dive into it a little bit more. But we've been receiving a lot of feedback from the community and from our customers recently. Actually, what's happening under the hood in AOSP? We've been working around the AOSP space for a few years, but over the past year, we made a huge leap in the way that we accelerate AOSP, and we've gotten great results that we wanted to share with you today. So let's get started. We've kind of collected a few questions from customers and through different AOSP communities that we're part of. And I think the most urgent question is for Dory is what's actually changing in AOSP build? Why is it suddenly such a hot topic? So let's start with that.
So thank you, Peleg. So I think it's always changing. It's a hot topic for a while now, but I think it's getting hotter. A lot of things are doing AOSP. It's getting more and more popular. And with the popularity, there is a variant explosion. More targets, more products, as probably the listeners can relate to. And we see that more and more, and it's actually getting bigger and bigger. The number of variants and targets people are running makes it slower, makes it more cherry picking. The pipeline itself, the AOSP build pipeline itself, is also changing. In the past, if we looked at the AOSP 10, it was mostly C++, but as the pipeline and as the AOSP is evolving, you see more languages, you see Rust, you see Java, you see Kotlin, a lot of other tools. It's becoming more complex. There are more input. The build is larger. Some of the targets, for example, include something like 8 million input files, which is crazy number. And this leads directly to build penalty. So even on very large CPU machines, builds are taking long time. When I'm speaking with large prospect and customers, they suffer from build times that can take from 2 hours up to 6 hours, which is crazy in today's world of rapid iteration. And what makes it even more problematic is the amazing trend that hopefully we all love of the AI coding assistant and coding agents, which creates a lot of overload on the CI when used properly. One of the largest OEM I recently spoke with told me that they have 40,000 builds per month running in their divisions. Uh, the number of commits is growing, and they expect it with AI now to triple just in 2026. So what we are expecting is a boom of AI velocity, and that AI velocity is being stagnated by slow pipelines, slow builds that kind of not allow organizations to tap into that. And this is becoming, from a lot of prospects and the customers I speak with, this is becoming a huge bottleneck. And in order to kind of open the ability to tap into the power of AI agents, you need to open the build pipeline. So what used to take in developing code used to take a few hours, now take a few minutes, but build time is still a few hours. So the percentage of build time compared to the time it takes to code highly increased and will increase more in the next coming years. So it becomes a real problem that needs to be addressed today in order to tap into the velocity that AI agents are capable of bringing.
Amazing. And I think that the AI velocity gap is something that we're hearing about more and more. We're seeing huge asymmetry between the number of code generated and the infrastructure. So the next question, it might seem a very trivial question, but okay, so my builds are slow, maybe they can be faster, but who really cares? How does it really affect my my organization and my product?
Actually, I'm at Incredibuild for many years. So I've been hearing of slow builds, for I think something like 15 years or so. And it always amazes me that people are okay with the long build times that they have. Many times is because they don't know that there are alternatives. Many times they try to solve it, but it's very complex. But slow builds actually affect, everyone in the organization. It affects the entire pipeline. It affects developers with slow iterations. The AI feedback loop, which is a huge thing that we already discussed, but it's going to be even much higher in the very near future. It's going to kind of rapidly become more and more effective, and the pipeline takes time to address them. So they need to be addressed today. When the builds are getting longer, commits are getting more frequent, the build queue accumulates, especially before releases at peak times. You have more and more builds waiting in the queue to be executed. There are more full rebuilds, things that are changes and require either full rebuild or semi-full rebuild, take a long time. And also this time translates to a lot of resource consumption. It's whether you need to buy more capex and more build servers in your on-prem and cooling and whatever it is in order to support it if you're running on-prem. And if you are running in the cloud, it translates directly to cloud costs. And of course, the main thing that interests business is the release friction, the iteration frequency, the ability to release in time in a predictable manner. So this is affecting everyone.
Amazing. And so we've seen a bunch of different solutions, and I think you'll talk about some alternatives at the end. But what in your opinion, and of course there's always room for improvement, what would you say is the optimal accelerator look like specifically for AOSP type builds that we've seen so far?
So when we thought about how AOSP accelerator should look like, what would be the principles, guidelines that should guide us when we saw this huge amount of build time and we wanted to accelerate this, we had a few things that we thought should be, the backbone of anything that want to solve this problem. So first and foremost is that, really dramatic build time reduction. We're not speaking about 30% or 25%. We're speaking about dramatic build time reduction. This should be the key, the key thing that anyone needs to have. Another thing that we thought is very important, even must have, is that people don't need to change their build tools or their build scripts. They don't need to migrate, what they're working with. For many reasons, it's both the risk of migration. AOSP is huge. it continues to evolve. So every time you have new AOSP versions and you need to migrate these versions as well, change these build scripts. There is, the build script, the build tools themselves, and changing them, and kind of each, iteration, just to keep, new versions. And it's not only to migrate it once. I think one of the problems is when you need to migrate your build script is that you need to continuously maintain them. So we thought that zero maintenance for anything that will accelerate your AOSP build is also something which is very essential. It needs to serve you. You don't need to serve your acceleration solution. It should work with any AOSP version, or at least, from AOSP 10, 11 up to the new ones. And when you have new AOSP versions, you don't need to kind of do huge amount of work anytime in order to support it. Even if you want to try, for example, AOSP 17 is coming very soon. People are already trying it. They should have the same acceleration tools that they used for AOSP 16, should allow them to iterate on their first tries of AOSP 17. And not only AOSP, it should support, when we're speaking about automotive companies, they have a lot more than just AOSP. They have AOSP, they have QNX, they have Yocto. In ADAS, they have Linux kernel, many other projects. It doesn't make sense to, migrate all of them or have different solutions, each serving different projects. You want to have one solution that will accelerate everything that you have in your dev organization. It's important to have compute efficiency. So you won't need to spend a lot of money in the cloud. You won't need to buy more servers and more compute and more memory in order to meet with the increased demand for compute in both AOSP and other projects as well. As I mentioned, 120,000 build per month. This is something that will require a lot of compute, unless it will be compute efficient. And compute efficient cache is by far and foremost, the way to do that. It's always much faster and much, economic not to run something than to run it fast. And cache first is something that we thought should be the backbone of such a solution. And of course, with anything that is complex, build analysis, build visualization to be able to understand, where your bottlenecks are, whether your build is healthy or not. This is an essential part of an accelerator solution.
And I think that it's a very interesting approach. And I think around about a year ago, when we started working on the new solution, putting these pillars as the baseline for what we expect to be the optimal solution. It's a big stretch, and it leads to my next question, which I think is a very interesting question. What other options are there? What kind of challenges am I facing with these options?
Yeah, so Incredible is not alone in how to work with an accelerator AOSP. There are various options. I think the most popular that I've seen when speaking with customers that they examined is one of them is Zcash, which is an open source for C++ acceleration. And it's a good solution. It's there for C++, but as I said, AOSP is becoming more complex, more multiple tool, and it's no longer only C++. Very, very much not so. As you can see, it's in terms of number of tasks, C++ is actually less than 25% of an AOSP common target, and it's actually getting less and less on each AOSP version. If you take a look at AOSP 12 and evolution towards AOSP 16, you will see that other tools, other languages like Rust and Java and Kotlin are taking a larger portion of an AOSP build. So when you're just using Zcash, you're leaving a lot of performance, a lot of efficiency on the table, and it's just not enough. And there are also other limitations as well as an open source, the ability to really reuse, the part of the cache that you want to have. the tools that accompany it, the ability to optimize it further, etc. It's limited, but it's there. The the other different angle, the different approach is the Bazel approach, which says, we can you can do anything. It's open. You can make your own rules. You make your own kind of build script, but this is what you need to do. You need to rewrite, you need to migrate your AOSP to Bazel. This is hard work. It requires a lot of risk and a lot of expertise in Bazel, in the way Bazel work. Google has a lot of tools that they develop that are not part, of the Bazel ecosystem out there. So you need a lot of these in order to be confident with your Bazel migration, especially for large projects such as AOSP. And you need to do that per version, and you need to continuously maintain that. And maintaining it is actually, from what we're speaking with customers, it's even more costly than the migration itself, because every time a file change, the developer is adding something, they need to go and add it in the Bazel script themselves. They need to be familiar with that. It's not as trivial to run it in developer workstation that it is to run it in CI. And usually you need a dedicated team, depending on your project. From what I'm hearing, a team between something like 6 and 10 people, just Bazel engineers to support it. It's not for everyone. It's also risky. It's something that takes time. And for AOSP 17, for example, you need to redo part of the work, and sometimes you need to do part of the work when a new Bazel version is introduced, like Bazel 9 was recently introduced with many changes that require a lot of maintenance work in order to continue and work with it. So these are two valid solutions. They have their pros and cons like every other thing.
Amazing. So I think we sorry.
Yeah.
I think we got to the first of all. I think about a year ago when we thought Ccache was our higher bar for acceleration, and suddenly we're looking back and seeing how far we've gone from that kind of acceleration. So I think we've gotten to the main event. We've kind of gave a very deep background, and now let's hear what our solution basically looks like, how the architecture looks like, and the solution itself.
Yeah. So let's delve into that. So the principles, we really wanted to meet them. So it took us a while to actually do that. And this is what we actually achieved. The ability to give you something which is very much like Bazel in a sense, universal caching, shared caching, multi-tool, fastest possible performance. And if the caching doesn't work, you have cache misses, then you have distributed computing, the ability to distribute processing across nodes in the network. This can be either dedicated nodes, it can be cloud spot instances, it can be idle CPUs just lying there idle across your network. And with Incredibuild, one of the things, I will not go into the technical part, but we can distribute cache misses into other machines seamlessly. And we do that while automatically creating a sandbox for these processes to run on these remote machines. So nothing needs to be installed on the remote machines, but besides a small Incredibuild agent, you don't need to have your environment there, your files. Incredibuild do that automatically. Imagine something like containers on demand. So we do that seamlessly. Essentially, the distribution infrastructure is really as if every developer workstation or build server becomes a supercomputer with hundreds of cores seamlessly. So it's not only for compilations, it's for anything in AOSP, and we'll see that in a minute. So the ground thing is first, see if you can cache reuse. And if you can't cache reuse, try to distribute that. Last thing, if you cannot, just run it locally. And I think the main thing with Incredibuild principle that we were able to capture is that you don't need to do any changes to your build tools, to your build scripts, to your workflow. Sometimes it sounds like magic and people really want to delve into the technology, and I hope we'll have some time to do it here. If you'll have more questions, you can ask them in the Slack channel or contact us for more information. But essentially, this is what we are able to achieve. So it's the same tools, Sung, Ninja, the same build script. We are not touching anything. Just beneath it, powered by IncrediBuild, universal caching, shared across organization, never run a task twice. If it's cache misses, everything can be distributed across machines without you needing to change, without you needing to maintain. It's as if you're working, with the tools as you do today. And it works seamlessly across AOSP versions. So the same solution without any migration, any effort. Your AOSP 12, 13, 14, 15, 16, the various variants. And not only that, but also any other build that you have as part of your network. I mentioned here QNX, Yocto, kernels that are very common to go side by side with AOSP. But essentially, anything that you have, any project, whether C++, whether it's Rust, and actually even other workloads that are not necessarily builds. It can be code signing, packaging, dynamic code analysis, linting, code coverage, static code analysis, anything that is time-consuming, anything that is deterministic in terms of execution can potentially be accelerated with IncrediBuild's universal cache and universal distributed processing. And on top of that, the visibility, the ability to visualize your pipeline, to visualize your build, to visualize your hit-miss analysis, and learn more on your bottlenecks and how to improve. How we do that? I won't be able to go into all the nitty-gritty, but essentially, we're starting with instrumenting and intercepting the processes. With this instrumentation technology that is injected to every process that's running as part of a workload, IncrediBuild can observe and understand, all the inputs that any process is accessing, and what the outputs that are generated as part of this input results in output. The inputs can be files, it can be environment variables, it can be command line arguments, and these inputs are hashed versus the output that was generated by the process. So anytime a process is running anywhere in the network, as long as the inputs didn't change, IncrediBuild will bring the results from the shared cache instead of re-executing it. And if we have a cache miss, the distribution will kick in, and IncrediBuild will run it remotely, distribute all these parallel tasks across a network of idle CPUs across the network, and make it much faster. So essentially, it's cache what can be, cache reuse what you can, and if you cannot, just distribute them. So benchmarks, right?
Mm-hmm.
I think everyone's interested with the numbers, so let's
see
into
some
them.
numbers.
Yeah. So we're speaking about, of course, there are many variants. We just chose one of them. And this AOSP 16 variant, it took almost 2 hours to run on a 32 cores. If you're looking just C++, it's more than 30 minutes. And with IncrediBuild caching, it takes 17 minutes. So it's X7 from the original time it takes, which is very dramatic. And I think this is the norm for vanilla AOSP 16 that should be from now on. Of course, people are not running vanilla. Many times they run their own custom stuff. So on top of their custom stuff, IncrediBuild can accelerate this further. When we're speaking about other builds, for example, these are live results. So when you're looking at live projects, large OEMs, 3 times, and QNX, from 50 to 18 minutes, ADAS and Yocto, and these are just some examples of live projects that we accelerate, not the vanilla. But essentially, we have a lot of case studies in our website or other projects that you can check for yourself. and build visualization. So you can see, all the tasks that are running. You can see where you can break it down, where you have cache misses and tasks are running, how many of them are distributed, full analysis and visualization tools that accompany that. So let's take a look at what's next. So next thing, which is something we're working on already, is bulk caching. And essentially, when we spoke about the previous caching, we spoke about the ability to cache, all the tasks that were part of an AOSP. So it's the Rust compiler, the Java compiler, uh, Ninja, CMake, Make, a lot of AOSP tools like AOSP IDL and packaging tools within AOSP, Kotlin compiler, etc. So these are still, if you're looking at an AOSP build graph, these are still the lives, the tasks that eventually are getting executed. And incredibly, instead of executing them, bring them back from the cache. With bulk caching, we eliminate entire graph branches. So when we're speaking about leaf caching, which is what we're showing today, Ninja CCATI still generates the build script. Ninja still go over them and executes the C++, the Clang processes in order to compile. And when we're speaking about branch caching, if nothing changed, CCATI doesn't need to run. Ninja doesn't need to run. So we're skipping an entire branches of execution altogether and bring all of that from the cache. When we're running very naive tests in our lab, we can see an AOSP without any changes, AOSP 16 from the 17 minutes reduced down to 7 minutes. And these 7 minutes consist mostly of 2 minutes that takes to hash all the input files, and then 5 minutes to copy all this stuff from the shared cache to the local machine. So the next step that makes sense, and this is something that will come after bulk caching, will be to give you the ability to have build runners within your private cloud. So the cache will be pre-warmed, so you won't need to copy things from the shared cache. So these 5 minutes can be essentially eliminated. Also with the 17 minutes, also if not bulk caching, still most of the stuff will be pre-warmed. And not only the cache will be pre-warmed, but also your Git will be pre-warmed, so you won't need to do pull Git, an entire pull Git, just the incremental Git pull. So we hope to be able to drive that into just a few minutes of AOSP build if no dramatic things are changed from previous execution. Everything will be very cost efficient in terms of cloud costs as well.
Amazing. So we're a minute over time. I think we'll wrap up. First of all, I'll say a big thank you to Dory for his time and for the depth. If any of this sounded interesting to you and you think it could be interesting for your organization, as we mentioned, we're offering now a free site survey, which basically means our team will collaborate with your team to form some kind of assessment to analyze what actual potential acceleration potential lies within your pipelines. And we'll see if the solution could be relevant for you. We'll send you a link in the chat here and later on mail for the site survey. Thank you everyone for your time.
Thank you, Peleg. Just one last thing to mention is that with the site server, we can tell you exactly where your bottlenecks and where you can improve and how much performance you can get at the end. And we also added support for Gradle, for Android apps. So these are also eliminated. It's not in the AOSP vanilla, but it's part of the custom AOSP builds. So this is also part of the site server, and we can tell you also how much you can cut on that.
Mm-hmm. Thank you. So the link is also in the chat, so you're welcome to click and book your assessment there. Again, thank you everyone for joining, and have a good day.
Thank you.
Thank you.